Hello, everyone. Welcome to 13.8. This will be our last lesson of the year. We're starting to look at the reciprocal functions of each sine, cosine, and tangent. So just to review what reciprocal is, a reciprocal is when you have a fraction and you interchange the numerator and denominator. And that's going to be very similar to what we are going to talk about here with these trig functions. Each trig function has a special name for its reciprocal. First is cosecant. Cosecant is the reciprocal of sine. So it can be written as 1 over sine theta, or you can think of it as 1 over the y coordinate. So recall that sine relates to the y coordinate down here on the unit circle. Cosecant is 1 over whatever that y coordinate is at theta position. Secant relates to cosine. Cosine, 1 over cosine, so we could think of that as 1 over x. Cotangent is 1 over the tangent of theta, which when you reciprocal tangent, that would be x over y. So before it was y over x, now we are for tangent, then cotangent is the x coordinate over the y coordinate. So you will notice that we are going to attack these problems very similar to when we were finding sine, cosine, and tangent on the unit circle, except now we are going to be taking the reciprocals. And you'll see kind of how those reciprocals fall into place here in a second. So let's head to problem 1, part A. And I'm going to zoom back out a little bit so we can see our unit circle. So part A, we are looking for what is the secant of negative pi. Now the secant relates to cosine. So this is going to be 1 over the cosine of negative pi, which also you can think of it, it's going to be 1 over whatever that x coordinate is at that position. So you go to your unit circle and you search for where negative pi is. Now negative means I'm going to go in the clockwise direction. So I'm going clockwise, pi radians, it's going to bring me right to here. Then I look at the x coordinate, negative 1. So that's going to be 1 over negative 1, 1 over the x coordinate, 1 over negative 1, which still just ends up being negative 1. So there would be my secant of negative pi. It's the reciprocal of that cosine at negative pi, which still is going to be negative 1. So that's a reciprocal of negative 1 will still be negative 1. Next, we're going to go to cosecant. So cosecant of 5 pi over 4 is talking about 1 over the sine value at 5 pi over 4. And moreover, that just is going to mean that we are doing 1 over the y coordinate. So I'm going to search for 5 pi over 4, and I'm going the counterclockwise direction, positive, looking for 5 pi over 4. It's going to bring me down to here. And if you're having trouble seeing my unit circle, you have your own unit circle. I also posted a unit circle back in the folder 13.2 that you can reference. And then there's your y coordinate. So negative root of 2 over 2. I'm going to zoom in just a little bit. So this is standing for now 1 over negative root of 2 over 2. Now here we have a complex fraction. 1 divided by negative root over 2 is like 1 times 2 over negative root of 2. Then we would need to rationalize. So we multiply by the root of 2, multiply by the root of 2. Okay, in our numerator, we're going to have 2 times the root of 2, which is 2 roots of 2. Denominator, we're going to have negative root of 2 times the root of 2, which is negative 2. The 2's will reduce out, so we're just left with negative root 2. So there would be my cosecant at negative pi over 4. And that negative sign kind of got covered up. So it'd be negative root of 2 at that position. Thirdly, we have a cotangent of negative pi over 3. And I'm going to have to scroll down to get some more room for this one. So negative pi over 3, I'm going to locate that. And then to find your cotangent, it's the reciprocal of tangent. So I'm going to take now the x-coordinate over the y-coordinate. So negative pi over 3 means that I'm going to go in the clockwise direction, pi over 3 radians. If I look at my unit circle, counterclockwise direction would bring me to here. Now that means then if I go in that clockwise direction, it's going to bring me down to this position. And then there's my x, there's my y. So to find the cotangent of 5 pi over 3 is the same as negative pi over 3, but we're going to find the cotangent of negative pi over 3. That's going to be the x-coordinate divided by the y-coordinate. So the x-coordinate is 1/2. Y-coordinate is the negative square root of 3 over 2. Again, we have a complex fraction, so we're 1/2 divided by the negative root of 3 over 2, which means I'm going to take 1/2 times 2 over the negative root of 3. 2's will reduce out. We're left with 1 over negative root of 3. And rationalize, we'll multiply by the root of 3. Multiply by the root of 3. We're going to get the root of 3 over negative 3. So there would be my cotangent at that position. So a little bit of work to do with these radicals, rationalizing, making sure that we have a rational whole number in the denominator, but there would be your cotangent. So very similar to how we practice finding sine, cosine, and tangent, we're going to go find where that theta value is and then use the x-coordinate, y-coordinate, or in cotangent's case, we use both the x and the y. We're going to take x divided by y. Another thing that you will notice is that when you're finding, like for example, the cosecant of 5 pi over 4, all we're doing is, since the sine is the y, that negative root of 2 over 2, all we're doing is just taking the reciprocal of that value. So yes, here's the math behind it. I'm doing 1 divided by negative root of 2 over 2. But all that really happens is I just am finding that reciprocal right there. So anytime you're looking for a reciprocal, secant, cosecant, you're just taking the x-coordinate, y-coordinate, whatever you're looking for, and you're just making that a reciprocal. And if you need to, yes, you do need to rationalize your denominators. But there is kind of a background just getting started with these reciprocal functions.